Yes, hi. I hope that everybody is doing good and your learning is going good. Huh? So I am Ashutosh and I am here to teach the structure of atom chapter to you. And we already completed a series of 7 lectures. Okay. So now this is the last lecture of this whole series. So this is the 8th lecture of this structure of atom chapter of class 9th. In this lecture, we are going to learn some you can say very important things, very important theory, and like the way electrons are going to fill the atoms and all, okay, based on the quantum mechanical model of the atom. Okay, so let's start. Yes, so yeah, today we are going to have these topics. We are going to first discuss what are the quantum numbers, and then distribution of electrons according to spdf configuration, and then Aufbau principle, and then Hund's rule of maximum multiplicity. So these are the topics which we are going to cover in this class, in this lecture. Okay, so first let's start with the quantum numbers. So before starting this quantum numbers, I just want to explain the quantum mechanical model of atom in a very brief, okay, just a brief introduction of what is the quantum mechanical model of atom. So we have this quantum mechanical model of atom, okay, in which we can say that we all know that we had these shells, okay, in Bohr's model, shells or energy levels, okay, and then these shells were also called orbits. Now here in quantum mechanical model, these shells will be represented by n is equal to 1 or n is equal to 2 or n is equal to 3, like these, as they are very similar to that the energy level which we learned in case of Bohr's atomic model. Okay, now these shells will have subshells in it. Okay, so like subshells. Okay, if let's say n is equal to 1, so n is equal to 1 means like the first orbit, and it will have only one subshell, s subshell. Okay, s subshell. If n is equal to 2, that is the second orbit, second shell of the atom, it will have two subshells, s and p subshells. Okay, then and if n is equal to 3, so then how many subshells this n is equal to 3 shell will have? 3. Very good. So s and then p and then d, like this. Similarly, we will have next shell, and then we will have next subshell, higher subshells and all. Okay, now, so all these subshells, now shells have subshells, and all these subshells will have orbitals. Orbitals. Okay, and these orbitals will have electron. Okay, these orbitals will have electron inside. Okay, so it means that there's shell. Okay, we can say that shell is like a society, okay, in which there are many buildings. Okay, or we can say shell is as a building or a house, okay, in which there are many rooms. So these subshells are like rooms. Okay, and these rooms will have, you can say, different beds. Okay, on these different beds there are people. Okay, so like this we can say, or we can say there's a building in which there's a house, and then there are rooms, and then people living in those rooms. Okay, now we can take any example. Okay, now let's see this with some example, huh? Let's take hydrogen first. So hydrogen has one electron only. Okay, and in first orbit, so we can say that hydrogen will have first orbit and it has one electron only. Okay, so it means that hydrogen has one electron in s subshell of first shell, first shell. Okay, like this. Okay, let's take these values. Let's say these shells will have values n is equal to 1 2 3 4. So the first type of quantum number which we are going to encounter, okay, which we are going to learn about, is principal quantum number. Principal quantum number, which tells us about the shell in which electron is there. Quantum numbers are actually represents the address of, okay, quantum numbers are going to present or tell us the address of an electron. Okay, so whenever we are going to know the where the electron, this particular electron resides, we'll know the we'll be able to or we are going to know the quantum numbers. Okay, so like by the quantum numbers we'll be able to know or locate exactly where the electron resides inside the atom. Let's see. So principal quantum number is represented by n, and it has values 1 or 2 or 3 and so on, okay, based on the shell in which the electron is there. Okay, now then for after this principal quantum number we have another quantum number called azimuthal quantum number. Azimuthal quantum number. Okay, so you will learn about these in detail in class 11th. Azimuthal quantum number is, so principal quantum number tells us about the shell. Azimuthal quantum number is going to tell us about the subshell in which the electron resides. So for subshell, if the electron is present in s subshell, then it will have a value of 0. Okay, it is represented by small l. So l will have a value of 0. If the electron resides in p subshell, then the value of l will be equal to 1. If the electron resides in d subshell, then the value is 2, and so on. Okay, like this. Then we have third uh, quantum number. But before that, let's learn something about orbitals. Okay, so s subshell will have one orbital, p subshell will have three orbitals, d subshell will have five orbitals, and so on. Okay, 1 3 5 like this. Then f will come and f will have 7 electrons like this. Okay, so if I uh, take this third quantum number, which is magnetic quantum number, magnetic quantum number, which is going represented by m, and which is going to tell us about orbitals, that in which orbital the electron is present. Okay, so if let's say we have electron present in s subshell, okay, so l will have value 0 and m will also have its value as 0 because s has only one orbital. Okay, if we have l is equal to 1, it means that the electron is there in p. Okay, and p has three orbitals. So like this, I'm going to draw three orbitals like this. Okay, so m will have a value of -1 for this, p 0 for this, and +1 for this. So it means that p will have a value, or magnetic quantum number will have a value from -l and then going to 0 and then coming to like +l. So -l to +l through 0. Okay, like this will be the value of magnetic quantum number m. Similarly, like if the electron is there present in d subshell, so then l will have a value of 2. So then l will have a value of 2 and m will have a possible values of -1, -2, 0, +1, and +2, like this. And d subshell will have 5 orbitals, 1, 2, 3, 4, and 5. So -2 is associated with this d orbital, -1 with this, and 0, and then +1, and then +2, like this. So this is how we are going to represent the quantum number and the electrons present in the atom. Now, fourth quantum number, spin quantum number. Fourth quantum number is called spin quantum number, okay, which is represented by S, and which tells us about the electron. Okay, now there are like two ways the electron can reside in the orbitals, like which is having a clockwise spin and the one which is having an anti-clockwise spin. So there are like two possibilities, two arrangements electrons can have, and similarly S can have a value of either plus half or minus half, based on that whether the electron is like this, okay, have an like upward direction, you can say, in representation, or anti-clockwise movement, or this like clockwise movement, so like plus half or minus half. So these are the quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum numbers. Okay, so we will learn about these in detail when in class 11th. Okay, for example, let's take one example, and then it will be clear to us all. Now if we want to, let's say we have sodium. Okay, so sodium has what is the quantum number values for, let's say, uh, for fifth electron of sodium, fifth electron of sodium. So then we will write the electronic configuration of sodium like this, which we are going to learn today: 1s2, 2s2, 2p6, and 3s1. So 11 electrons. These are the number of electrons: so 2 and 2 4, and then 6 10, and then 1 11. Okay, now when we are going to fill this, so this is 1s, it will have 2 electrons. This is 2s, it will also have 2 electrons, so 4 electrons are there. Now fifth electron will come in p subshell or not, and then we will have like this. So this is 2p6, okay, and then this is 3s1. So we can, these are our, this is the electronic configuration of sodium or not, and this is the fifth electron or not, this is the fifth electron. So we are going to write the quantum numbers for this electron. So what is the value of n? See, so n, since the electron is in second subshell or not, sorry, second shell, and that's why n will have a value of 2. Clear? Then what is the value of L? So L, like the electron is in p, so L will have value of 1 or not. Okay, and then what is the value of M? So we can say that when L is equal to 1, so it means that M will have -1, 0, and +1 values or not. Since the electron is in this -1 wala, so that's why M will have a value of -1. Okay, and then what is the value of S? It will have a plus half. So okay, these values, the you can say the set of this value is very unique. Okay, it will represent only this electron and not any other electron of any other atom. Clear? So this was all about quantum numbers. I hope you understood it. Now let's take another uh, next topic, which is distribution of electrons in spdf configuration. So let's talk about this Aufbau principle now. So Aufbau principle, as we are going to learn, Aufbau principle. Aufbau is a German word, okay, which means build up, actually building up. So Aufbau principle tells us about like how the electrons are going to occupy the atom. Okay, we can write like this: 1s, 2s, 2p, 3s, 3p, 3d, okay, 4s, 4p, 4d, 4f, and then 5s, 5p, 5d, 5f, 6x, 6p, 6d, 6f, and then 7s, 7p. Now, see what happens, that these are the subshells are written here. Okay, like first orbit, first shell will have only one s subshell, second shell will have 2s and 2p subshells. Okay, then third will have 3s, 3p, 3d, and 4 will have. Okay, so similarly these are the subshells written here. Now we are going to decide that which subshell will have higher energy and which subshell will have lower energy by this Aufbau principle. Okay, so we are going to do like this. Okay, so like cancel these. So this 1s, okay, 1s we'll write 1s, and then after 1s we'll have 2s, because see 2s, okay, then 2p and then 3s, so 2p and then 3s, okay, and then 3p and then 4s like this. Okay, so then 3d, 4p, 5s, 3d, 4p, 5s like this. So if we, let's say we want to write electronic configuration of calcium. Okay, calcium has an atomic number of 20, so then we will first write 1s2, because the first two electrons are going to enter into the 1s orbital, 1s subshell. Okay, then next electrons will enter in second s, okay, 2s. Now it can occupy only two electrons. Okay, and that's why now the next, because one orbital will have only two electrons maximum. Okay, so s subshell has only one orbital, so it can occupy only maximum of two electrons, while p has three orbitals, so it can occupy maximum of six electrons, so then 2p6. Okay, now 10, 2 and 2 and 6, so it's 10. Now then next electron will enter into 3s, so 3s2, and then 3p2, sorry, 3p6, and then 4s2. So these are like to 20 electrons. Okay, so calcium will have its electronic configuration like this. Okay, I hope. Similarly we can write it for let's write it for zinc. Okay, so zinc will have 30 electrons. The atomic number of zinc is 30, so we can write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d10. Okay, see, so this is the atomic number of zinc is 30, and electronic configuration of zinc is, this is the electronic configuration of zinc. Okay, this is Aufbau principle. Okay, now next principle, next rule which we are going to learn is Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity is very important. Like we just wrote the quantum numbers of fifth electron of sodium. Okay, now if we want to write the quantum number of sixth electron of sodium, let's say, so then what are we going to do? Which electron is sixth electron? So this electron is considered as sixth, or this electron is considered as sixth? Which one? So let's talk of this Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity. It says that whenever electrons are going to enter in p, let's say p subshell like this, so then first all these orbitals will have one electrons each. Okay, like this, one electron here, one electron here, one electron here, then only they will get a partner like this. So, okay, then only the pairing of the electrons will occur. Okay, like if we want to write the electronic configuration of, let's say, boron. Okay, so boron will have 5 electrons, so we can write 1s2, 2s2, 2p1. So like this we can represent 1s2 will have 2 electrons. Okay, then 2s2 will also have 2 electrons like this, and then we have 2p1, so 1 electron in this. Then if we want to write for carbon, so it will have 1s2, 2s2, 2p2. Okay, so then we'll have 2 electrons here, 2 electrons here, 1s2, 2s2, and then we'll have 1 electron here and 1 electron here, so 2p2. Clear? Okay, because writing it like this is not correct. Okay, this is the correct form. Okay, similarly we can, like for nitrogen, we can write 1s2, 2s2, 2p3 as 2 electrons here in 1s, 2 electrons are present in 2s, and then 1 electrons in all these orbits, so 2p3 like this. This is Hund's rule of maximum multiplicity. Now if we have oxygen 8, 1s2, 2s2, 2p4, okay, so then we'll have 1 electron going to form a pair like this. Okay, so we are going to write it like this. So like we have 4 electrons, then 5th electron, then 6th, 7th, and then 8th. So the 8th electron is going to come in the first orbital of 2p. Okay, clear? So this is how we are going to uh, do the electronic configuration of various elements. I hope that you learned these things, these concepts of Aufbau principle and Hund's rule of maximum multiplicity, and all these about quantum numbers in this video. Okay, so yeah, these are the supporting documents, you can say PPT, which you can refer to. If you have any queries, anything you want to ask, okay, or you have any doubt, okay, so I request you all to just post it on forum, okay, and we are going to answer your queries, we are going to clear your doubts in this. Okay, so this is all for this chapter. I hope you enjoyed learning this structure of atom and you learned something at least. Okay, so thank you for your time. Thank you everybody. Keep learning from Ask IITians.